1973, a rusted F-150 hauling fence posts just outpulled a Chevy big block on a muddy Montana ranch. The farmer laughed. The Chevy driver didn't. Under that dented hood sat an engine Detroit tried to bury, an iron monster so tough it made diesels jealous, so simple a teenager could rebuild it in a barn, and so threatening Ford's own executives wanted it dead. This is the explosive truth behind the engine they called Bulletproof, the Ford 300 Inline 6, and the war Ford waged against its own creation. The world didn't need another truck engine in 1964. Ford's F-Series was already selling like hotcakes. Their flathead V8s and small-block Windsor engines were powering everything from work trucks to weekend warriors. But there was a problem brewing, one that kept Ford's truck engineers up at night. Fleet buyers were screaming for something different. They didn't want horsepower. They wanted reliability. They didn't want speed. They wanted torque. Low down, grunted out, all day long torque. And most importantly, they wanted an engine that wouldn't bankrupt them in maintenance costs. Chase Morsey Jr., Ford's advanced engine design lead, gathered his team in Dearborn. The mandate was simple but brutal. Build an engine that could survive 20 years of abuse, run on the cheapest fuel available, and cost pennies to maintain. No exotic materials, no complicated systems, just pure, unbreakable iron. What they came up with would change Ford's reputation forever, but not in the way anyone expected. The roots of the 300 trace back to Ford's earlier inline 6s, and the 215 and 223 cubic inch engines that powered sedans and light trucks through the 50s. These were good motors, reliable and smooth, but they lacked the grunt needed for heavier work. By the early 60s, construction booms and interstate highway projects created demand for trucks that could haul more, pull harder, and last longer. Ford needed to scale up, but smartly. Engineers started with a clean sheet approach. They took the inline 6 configuration, beloved for its natural balance and smooth operation, and beefed up everything. The block was cast thick and heavy, with reinforced webbing around the main bearing saddles. 7 main bearings, not the typical 4 found in most 6s. This spread the load across the crankshaft, reducing stress and wear. The crank itself was forged steel, not cast iron, expensive but nearly indestructible. The stroke was set at 4 inches, unusually long for the era. This gave the engine massive leverage on the crankshaft, translating to incredible low-end torque. Peak power didn't come until around 3,500 RPM, but by then the engine was already pulling like a locomotive. The bore was kept relatively small at 4 inches, which meant thick cylinder walls. Walls so thick you could overbore the block multiple times and still have meat left over. Introduced in 1965 as the 240 cubic inch version, it was clear Ford had built something special. But they weren't done. Just a year later, they bored it out slightly and stroked it to create the 300 cubic inch variant. This became the definitive version, the one that would earn legendary status. Rated at 150 horsepower and 283 pound-feet of torque, those numbers told only half the story. This engine made its power where it counted, down low where trucks actually worked. The simplicity was shocking. Single overhead valves, pushrod actuated, a cast iron head with relatively small ports, a single barrel carburetor in most applications, no fancy electronics, no complicated emission controls in early years, nothing that couldn't be fixed with basic hand tools. Fleet managers loved it, mechanics loved it, and farmers, construction crews, and small business owners quickly discovered they'd found a partner they could trust. Ford marketed the 300 as the workhorse of their truck line, the engine for serious buyers who valued substance over flash, and for years, that's exactly what it was: reliable, torquey, and utterly forgettable. But in garages across America, a different story was beginning. Hot rodders were looking at that long iron block and seeing potential Ford never intended. The transformation started quietly. A mechanic in California, a speed shop in Texas, backyard builders who couldn't afford big block engines but had access to junkyards full of 300s. They started experimenting. The first builds were crude, swapping on 2-barrel carburetors from bigger Ford engines, installing headers cobbled together from exhaust tubing, advancing the timing and running hotter spark plugs. The results were surprising. The 300 responded. It wasn't going to win drag races, but it could be woken up. Then came the manifold hunters. Companies like Clifford Performance and Offenhauser had been making performance parts for inline sixes since the 50s. They offered dual carburetor intake manifolds, rare and expensive, designed for Ford's smaller sixes. But with some machining and patience, these could be adapted to the 300. Suddenly, you could bolt two 4-barrel Holleys onto a truck engine. The sight alone was worth the price of admission. Installing a dual-quad setup on a 300 was like giving a cart horse racing shoes. The engine's long stroke and heavy rotating assembly meant it would never be a high-revving screamer. But with proper carburation, it could breathe. Airflow increased dramatically, fuel delivery became more precise, and the power gains, while not earth-shattering by big block standards, were significant. Some builders reported gains of 50 to 70 horsepower over stock. More importantly, the torque curve fattened up everywhere, giving the engine a muscular mid-range punch that could surprise small block engines. But dual carbs alone weren't enough for the serious builders. They wanted more. Enter the camshaft. The factory cam in a 300 was designed for low RPM efficiency with conservative lift and duration. Swap in a performance grind with longer duration and higher lift, and suddenly the engine could breathe past 4,000 RPM. The valves stayed open longer, allowing more mixture in and more exhaust out. Combined with the dual carbs, the 300 started to feel alive. Headers were the next step. The factory cast iron exhaust manifolds were restrictive, designed for durability and packaging, not flow. A set of tuned long tube headers opened up the exhaust side, reducing back pressure and improving scavenging. The effect was immediate. Throttle response sharpened, power climbed, and the sound, that deep mechanical howl of a straight six with open headers, became addictive. Ignition systems needed upgrading too. More air and fuel meant the factory points and coil setup struggled to provide consistent spark under load. High-energy electronic ignition solved this, delivering hotter, more reliable spark, even at elevated RPM. Adjustable timing allowed fine-tuning to extract maximum performance without detonation. It all worked together, carbs feeding air and fuel, cam optimizing valve timing, headers evacuating exhaust, and ignition lighting it all off with precision. When done right, a built 300 could push well past 200 horsepower, sometimes closer to 250 in aggressive setups. Torque figures climbed past 350 pound-feet. These weren't big block numbers, but they were respectable, and because the engine retained its low RPM grunt, it remained usable for towing and hauling, even with performance mods. You could drive it to work, hook up a trailer, and still smoke unsuspecting Camaros at stoplights. The visual impact couldn't be ignored. Pop the hood on a Ford truck or a Maverick with a built 300, and people stopped. Two chromed 4-barrels sitting atop a polished aluminum intake, braided fuel lines snaking through the engine bay, long tube headers wrapped in heat tape. It looked like something that belonged on a vintage race car, not a grocery getter. And that was the point. This was old-school hot rodding in its purest form, taking the underdog, the overlooked, the supposedly boring, and turning it into something special. The racing community took notice, but not in the way Ford expected. The 300 started showing up in places it had no business being. Circle tracks in the Midwest where budgets were tight and rules were loose, drag strips where bracket racers needed consistency more than raw power, rally stages where torque and reliability mattered more than peak horsepower, and tractor pulls where the 300's cast iron block and bulletproof bottom end made it a favorite. One of the most famous builds came out of Ohio. A small shop run by a guy named Leo Sanucci specialized in turbocharging inline sixes. In 1978, Sanucci built a twin-turbo 300 that went into an Econoline van. The setup was crude by modern standards: a pair of small turbos scavenged from diesels, a custom log manifold, and a carburetor that had been extensively modified for boost. But it worked. That van ran 12-second quarter miles, embarrassing muscle cars and confusing everyone who saw it. Sanucci later told CarCraft magazine the reactions were priceless. People scared the hell out of Camaros. The 300's bottom-end strength made it ideal for forced induction. The forged crank, heavy-duty rods, and thick cylinder walls could handle boost that would grenade lesser engines. Turbo and supercharger kits started appearing in the speed shop catalogs. Nothing mainstream, but enough to keep the dream alive. Builders discovered that with proper tuning, a 300 could safely run 8 to 10 pounds of boost on pumped gas. Power jumped to 300 horsepower or more, with torque figures that made diesel engines jealous. But just as the 300 was finding its stride in the performance world, storm clouds gathered. Inside Ford, a quiet war was brewing. The engine, that had become a favorite of fleet buyers and hot rodders alike, was being seen as a threat by the very company that created it. Ford's V8 divisions, particularly those responsible for the small block Windsor and big block engines, viewed the 300's success with alarm. Here was a 6-cylinder engine, cheap to build and maintain, that could do much of what their V8s could do. And it was stealing sales. Corporate politics turned ugly. Engineers who championed the 300 found their budgets slashed. Proposals for fuel injection, electronic engine management, and even a factory turbocharged version were killed before they left the drawing board. One retired Ford engineer, Frank Miller, later claimed in a forum that the team had begged for fuel injection development in the early 80s. The response from executives was brutal. Put it in a V8. The message was clear. The 300 was to remain a basic, utilitarian engine. Nothing more. At the same time, emissions regulations were tightening. The Clean Air Act and subsequent EPA rules forced automakers to rethink everything. The 300's simple design, once its greatest strength, became a liability. Without sophisticated engine management, it struggled to meet nitrogen oxide and carbon monoxide standards. Ford responded by detuning the engine, lowering compression, leaning out the carburetor, and adding restrictive exhaust systems. Horsepower dropped from 150 to 120 by the mid-80s. Torque fell too. The engine that had once been a powerhouse became a wheezy shadow of itself. Enthusiasts watched in horror. The 300 was being strangled by regulations and corporate neglect. Some blamed government overreach. Others pointed fingers at Ford's V8-obsessed management. The truth was probably a mix of both, but the result was undeniable. By the late 80s, the 300 was relegated solely to base-model trucks, the cheapest option for buyers who didn't want or couldn't afford a V8. The glory days seemed over, and yet the 300 refused to die. In Mexico, production continued into the 90s. In marine applications, the engine found new life powering boats and generators, and in garages across the country, a loyal cult of builders kept modifying, improving, and racing 300s. They weren't building for corporate approval or magazine covers. They were building because they loved the challenge, because there's something deeply satisfying about making an underdog engine perform beyond its design intent. The aftermarket, though small, remained active. Companies continued producing performance parts, intake manifolds, camshafts, headers, ignition systems. Nothing on the scale of small block Chevy support, but enough to keep the dream alive. Online forums became hubs of knowledge, places where builders shared dyno sheets, tuning tips, and war stories. The 300 community was small but passionate, united by a common belief. This engine deserved better than it got. One of the most intriguing rumors that circulated through enthusiast circles involved a secret Ford project. Codenamed Atlas, it supposedly involved a twin-turbo, fuel-injected 300 designed for a new Super Duty truck line. The goal was to create an engine that could compete with early diesel offerings, delivering over 400 pound-feet of torque while maintaining the simplicity and low cost of a gasoline inline 6. Development supposedly reached advanced stages in the early 90s, with running prototypes tested at Ford's Arizona proving grounds. Then, according to the rumors, the project was killed. Not for technical reasons. The engine worked, but because it threatened Ford's diesel program and their V8 lineup. If a turbocharged 6-cylinder could match or beat small block V8s in torque while getting better fuel economy, why would anyone buy the more expensive options? The Atlas project, if it existed, was buried. Blueprints disappeared. Engineers were reassigned or allegedly sworn to silence. All that remained were whispers and speculation. Was it real? No one knows for sure. Ford has never acknowledged the project publicly, but the story persists because it fits a pattern. The 300 had a history of being held back, of corporate decisions that seemed designed to limit its potential rather than unleash it. Whether Atlas was fact or fiction, it represented something real to enthusiasts. The belief that this engine could have been so much more if only Ford had let it. The 300 finally met its official end in 1996. Ford discontinued it in favor of newer V6 and V8 engines that could meet modern emission standards more easily. The last 300S rolled off the assembly line without fanfare, just another obsolete engine being put out to pasture. But for those who knew, who had driven them, wrenched on them, or raced them, the end felt like a betrayal. This wasn't just an engine, it was a piece of automotive history. Today, the Ford 300 lives on in a different way, in the hands of builders who refuse to let it be forgotten. Resto-mod trucks with fuel-injected 300s making 300 horsepower, off-road rigs running turbocharged setups that produce diesel-like torque, vintage race cars campaigning in nostalgic events, and thousands of work trucks still on the road, many with original engines that have run hundreds of thousands of miles without major rebuilds. The 300 earned its nickname, God's Anvil, because you simply couldn't kill it. The legacy is complicated. Ford created an engine that was almost too good at what it did, too reliable, too durable, too capable. And instead of celebrating that, they tried to contain it, limit it, eventually bury it. But the builders and enthusiasts who saw its potential never forgot. They kept the faith, kept modifying, kept proving that a simple straight six could hang with engines twice its cylinder count. So, what's the truth about the Ford 300? Was it corporate sabotage or just bad timing? Did Ford intentionally strangle their own creation to protect V8 sales, or were they simply reacting to market forces and regulations? The answer probably lies somewhere in between. But one thing is certain. The 300 Inline 6 was never given the chance it deserved. If Ford had invested even a fraction of the resources they poured into V8 development, who knows what this engine could have become? Imagine a fuel-injected, turbocharged 300 in a modern F-150. Reliable, torquey, efficient, a real alternative to diesel power, or a factory performance version, breathing through modern cylinder heads with variable valve timing, making 250 horsepower and 400 pound-feet naturally aspirated. These weren't fantasies. The engine's architecture could support it, but it never happened. The 300's story is a reminder that sometimes the best engines aren't the flashiest. They're the ones that show up, do the work, and ask for nothing in return. The ones mechanics trust, drivers depend on, and builders can't resist modifying. For 31 years, the Ford 300 did all that and more. It powered America's work, built its infrastructure, and earned a reputation that outlasted the corporate politics that tried to suppress it. Was the 300 bulletproof? Ask anyone who's owned one. Ask the cab drivers who racked up 500,000 miles. Ask the farmers who ran them 24/7 in irrigation pumps. Ask the hot rodders who boosted them to twice their factory power and drove them home. The answer is always the same. Yeah, it was bulletproof, and Ford never quite knew what to do with that. The explosive truth behind the Ford 300 isn't just about an engine. It's about what happens when engineering excellence collides with corporate fear, when a simple, honest design threatens complicated business plans. The 300 was supposed to be a basic truck motor, nothing special. Instead, it became a legend, not because Ford wanted it to, but in spite of everything Ford did to prevent it, and that, more than anything, tells you everything you need to know about this cast-iron masterpiece.